So the good thing about these notes today is that this is not that hard. It's pretty simple. It is going to go quick. You're going to have time at the end of class to work on your homework, which is nice because you guys have a quiz tomorrow. All right. So along with the homework, I also created, I think there's 28 Alex problems. Are you and Alex Takeem? Are you sure? Ask me to double check afterwards. I'm pretty sure I put you in there. And I'll show you how to get in there and what to do. But it is optional. Okay, so I'm not giving you double homework tonight, but I think that, you know, your first quiz of the semester, we want to rock it and come out shining, right? So I want to make sure that you have all the practice that you need. So I literally went through the quiz that I made and picked out problems to help you prepare. Okie dokie? So take that into consideration while you're working tonight. Make some time to do that. All right, so 10.5, it's called mutually exclusive, or we have not mutually exclusive events. Guys, this is very similar to what happened and what we did yesterday, except all the problems that you see today are going to contain the word or. They're going to contain the word or. So let's just talk about this word. I'm not going to get too hung up on this mutually exclusive idea, but when something is exclusive, what does that bring to your mind? Have you ever been to like an exclusive club? Something like that? Or maybe got like a privilege? Is something exclusive happening all the time? No. It's pretty rare, isn't it? So if something's mutually exclusive, that means that these two events are not going to happen at the same time, or you can put cannot happen. They will not ever happen at the same time. This is so similar to independent events, all right? Very, very similar. All right, so the outcomes, no outcomes are in common. I'm going to go through these first three are all mutually exclusive events. So none of the events are going to happen at the same time. So number one, when a die is rolled, what's the probability of getting a 3 or a 4? So let me ask you a question. When you roll a die, you know you're going to get one of these two. That's what makes them mutually exclusive. You can't get a 3 and a 4 at the same time. That's never going to happen when you roll one die. So that's what makes them mutually exclusive. Now, how do we find the probability that you're going to get a 3 or a 4? So think about when we do probability, we've got total outcomes. What's the total outcomes on a die? 6. That's easy. You guys know that. Total outcomes on a die is 6. And then we want on the top what we want to happen, right? What's the likelihood of getting a 3 or a 4? So these are both okay answers. You can get either one and that's the outcome that you want. So there are 2 of them. So this is 2 out of 6 or 1/3. Because if I roll a 3, I'm happy. If I roll a 4, I'm happy. It's 3 or 4. You with me? Both of them come together. All right, so in this one, I want you to think about adding. Whenever you see the or, I want you to think about adding those things together. Maybe you want to make a little note. That little or is going to mean add things together. Yesterday, we did what word? What word? And. Everything in your homework and everything in our notes yesterday was the word and. And what did we do with all our probabilities yesterday? We multiplied them. So now when you see or, you're going to have to add them together. It's not that bad. All right, number 2. Daniel organizes all of his social media contacts into 3 groups. And you can see the 3 groups that he has in the little chart down there. We've got close friends, acquaintances, and restricted. If the program sends Daniel an update from a randomly chosen contact, what is the probability that the contact is either a close friend or acquaintance? Okay. So remember, or means what? Add them together. So we're going to do close friend or acquaintance. So how many contacts is that? 92, says the king. Very nice. 92 contacts. And what's the grand total of contacts? 102. Are you going to leave your answer like this? I hope not. You're dividing it by 2, right?
Yeah.
92 divided by 2 is what?
46.
46. And 102 divided by 2 is?
51.
51. Can we reduce that any further? No, we can't. That's it. 46 out of 51. That's the probability that he gets a close friend or an acquaintance. Okay, so you're looking at both groups together. All right, number 3. I chose number 3 to go over because this is kind of like what the SAT does to you. They give you like a super huge word problem. Some of the parts of the sentences you don't even need. It's just extra fluff. And then they give you things to look at that look incredibly difficult. This is not a difficult problem, by the way. Let's read it together. Of the more than 79,800 species of on a red list of threatened species, that's a lot of threatened species, isn't it? Seabirds are of particular interest because they are indicators of broader marine health issues. The circle graph shows the proportion of seabird species in each red list category. So what's the circle graph all about? What's the circle graph down here about?
Seabird.
Seabirds, guys. It says it right there. The circle graph shows the proportion of seabird species. So these are the little area where they are extinct. That's sad. These are the ones that we're not even concerned about. And do you notice they give you what kind of information on the circle graph? What are they giving you? Say that again, Nevaeh. The number and the percentage, right? They give you both. They give you both of them. So does it matter which one you choose to work with? I'm going to work with the percentage because we haven't done much with percent, so we're going to go ahead and work with the percent. You can do the number and you'll get the same exact answer though. So it says, what's the probability that a randomly selected species of seabird is on the critically endangered list? So there's one of them, critically endangered list, or add it together, endangered list. So find the critically endangered. What's the percentage for critically endangered, Gabriel? 5% for that one. And what's the percentage for endangered list, Timmy?
9%.
9%. All right, so if I turn 5% into a fraction, what do I get? 5 over 100. And 9% as a fraction is 9 over 100. So when I add them together, what is it? 14 over 100. Now, if I want to make a percent answer, what's the percent answer going to be?
14 over 100.
Yeah, 14 over 100 is 14%. So you could give it like that. If I wanted to make a fraction answer, what would I give it as a fraction?
7 over 50.
Yeah, reduce your fraction to 7 over 50. Okay, so either one is fine. It doesn't specify in the problem which way to give the answer, so you're fine either way. Okie dokie. All right, any questions so far? Is this pretty simple? I know, we love probability, don't we? Now, if you take a statistics class in college, which many of you will, I just want you to remember this is the foundational part of it. So they'll probably do a lot of the things that we're doing right now in the first 2 classes, if not just the first class, depending on how you're taking your course. But it'll go further. All right, so now we're going to turn the page and look at not mutually exclusive events. These are much like our dependent events. It means that 2 events that can happen at the same time, right? They're not mutually exclusive. They can happen at the same time. So number 4, when a die is rolled, what's the probability of getting a number greater than 2 or an even number? And I gave you a little Venn diagram on there. So what do you think the probability is going to be? We're going to add them together still. It's still an or statement. I'm going to let you guess without even telling you. What do you think makes sense? Still or? Yeah, putting them together. Hey.
Why is 1 like out of the way?
Oh, that's a good question. Why is 1 down here? Anybody got an answer for that?
Is it because it's less than 2 and not even?
Okay, it doesn't fit into one of these two categories, does it? One is odd, so it's not the even, and it's not greater than 2, it's less than 2. So that's why it's down here by itself. Am I freaking you out? What do you think it might be, Nevaeh? 5 over 6. Any of you boys want to take a guess? Joshy, what do you think?
5 over 6.
5 over 6? It is 5 over 6. Guys, this is or. Or means everything together. If I tell you you can have cookies or ice cream, right? Are you wrong if you select one or the other? It doesn't make a difference. You just got to get one of them. Okay? So in this selection, you can pick from all these numbers or all these numbers. And that's 1, 2, 3, 4, 5 different numbers that will work out of how many? 6 of them on the die. So that's 5 out of 6. You don't want to count these twice. So even though these are overlapped, don't count them twice. All right? They go in both groups, but you don't count 4 and 6 twice. Okay, number 5. Number 5, a card is drawn from a standard deck of 52. Determine whether the events are mutually exclusive or not mutually exclusive. And then, so remember, mutually exclusive means they cannot happen at the same time. Mutually exclusive means they do happen at the same time. And then we're actually going to find the probability of these things. So letter A, drawing a 3 or a 2. So you've got a deck of cards. You want to put the probability of drawing a 3 or a 2. Is that mutually exclusive or not mutually exclusive? What do you think? Can they happen at the same time?
No.
No, they cannot. So they are mutually exclusive. I'm going to do a little ME for mutually exclusive. They cannot happen at the same time. They are mutually exclusive. So let's find the probability for this. What's the probability of getting a 3? How many 3s are there in the deck? 4 of them. You guys with that? There's 3 of hearts, 3 of clubs, 3 of diamonds, and 3 of spades. How many 2s are in the deck? 4. So since it's or, we add them all up together, and that's 8 cards out of 52 cards, and we reduce it to 4 over... Oh, wait, we can reduce by 4, can't we?
Oh, yeah.
So we can do 2 over 13. All right, letter B, drawing a 7 or a red card. Can that happen at the same time?
Yes.
It can. So what do we call that? Is that mutually exclusive or not mutually exclusive? Not mutually exclusive. This is not mutually exclusive. All right, so let's think about this one. How many 7s are in the deck?
4.
4. How many red cards are in the deck?
26.
26 red cards are in the deck. Now here's the thing. How many cards are both 7 and red? 2 of them. So you don't want to count 2 of them twice. All right? So instead of, yeah, so you could do like 2 plus 26, but it's just only 28 out of 52. Does that make sense? Are you guys okay with that? All right. And then we can reduce this by 4 again, so we get 7 over 13. All right, I'm going to let you try letter C, drawing a queen or a spade. A queen or a spade. I'm gonna come see what you guys are getting. You're right about that. you know playing games is good for your intellect? Those of you guys that are like, not that you have to play card games, and I'm not talking about video games. Video games are not good for your intellect usually. Usually those are actually bad for your brain. But like any kind of game that you have to think about like a couple of moves ahead of time, like checkers, chess, any of those card games where you have strategies, war not really one of them. Monopoly, some of those things, those are good for your brain. And it relaxes you too, it's nice. Video games do not relax you. Video games overstimulate your frontal lobe, which is bad for your creativity. Sorry. All right, so drawing a queen or a spade, is this mutually exclusive or not mutually exclusive? It's not mutually exclusive because they can happen at the same time. You can get the queen of spades, right? So this is not mutually exclusive. How many queens are in the deck? 4 queens. How many spades are in the deck? 13, but we've got to subtract for that queen of spade, right? We can't count that card twice. So we can get rid of one of these and just call it a 3. And what's 3 plus 13? So we've got 16 out of 52 could be queen or spade. And that reduces by 4 to 4 over 13 is the answer that you should get. Are we okay with this? Okie dokie. All right, number 6, last one for today. A game piece is selected at random from the plate. What's the probability that the game piece is round or orange? Now guys, that's the picture of the purple plate. These are the game pieces. So you're looking for round or orange. All right, let's hear what you're getting. Takeem, what'd you get?
4.
4 out of 10? Look for round or orange. There's more than 4. Round or orange. Count those up again, okay? James, what'd you get? 7 out of 10. Joshi? Yeah? Are we happy with 7 out of 10? Yeah, so there are 10 pieces on the plate, and if you look at round or orange, there they all are. There are 1, 2, 3, 4, 5, 6, 7 of them that are round or orange. Bam. Not bad, right? Okay, so here's your deal. This is your homework. It's not 1 equals 18, it's 1 through 18. Sorry about the typo. This is going to be due, we're going to go over this tomorrow before your quiz. We'll grade this. And then if you finish this in class, you can go ahead and start working on that Alex. But I hope that you take some time tonight to work on some of those 28 questions on Alex, just to get ready for your quiz tomorrow. What's up, Timmy?
What is a face card?
A face card is a card that literally has a person's face on it. So that could be... An ace does not have a person's face on it, just has the ace on it, an A. So it could be a jack, a queen, or a king. I'm pretty sure.